Right, Nick Mosley again here, U2CID KHY111. This is still coding problem set number 5, the Caesar cipher. This will be problem number 3, cipher text message here. So fairly simple here. Um, excuse me. Well, we're filling in the methods in the class cipher text message, and there'll be just two methods here. The decrypt message will be the big one here. But we have the first one here, so we are just setting this cipher text message object here. Excuse me. And then yeah, what we want to do is just, yeah, set this as similar deal. So we are just calling it back from the initial message class because it just has those two attributes. They were previously defined here for us, so we are just going to call them back here for the ciphertext message, and that will be the very first method here. Second one, bit more involved here, so this will be the actual decryption on the message, and so we are trying every possible shift value and finding the best one. Best is defined as maximum number of real words. When we use the apply shift on the text message, or excuse me, on the message text over there, yeah, we were told that the is underscore word, wordless word, and the string method split open parentheses as useful. Again, is word is going to ignore the punctuation and other special characters when considering whether or not word is valid here. And so, yeah, we were told that, we would expect 26 minus S to be the best shift value for decrypting it. So we're going to want to set a range of up to 26 here. And then the other thing is if multiple shifts are equally good such that they all create the maximum number, you can choose any number of those shifts. I kind of took the easy route here, I guess. I just kind of defaulted to you have to be better than the last best word here. Um, so yeah, not greater than or equal to, it's just you have to be greater than to best that best word. And so it's told to create a tuple of the best shift value. So that's what we've got here. We've also got this starter counter for the best words. Probably a little confusing there for actual code, but for these purposes, it'll work here. And then so we are just going to look in for that S and that range of 26 minus S here. And then for each word in the apply that shift, we are going to take a look at that word, see if it is a valid word. If it is, it's true. And then the count will plus or equal 1. It's going to be fairly simple in something like this because there's only one word. In our story mode, like, of course, it does have to kind of go through multiple words to make sure that it's all defined here. But as far as problem 3 is concerned, that is the logic behind that. Yeah, it's going to apply the shift to the word, which will be 0, it'll be 1, 2, 3 for each word, which in the initialized case it's just one word. And then it's going to see if it's a word, and if that's true, the count is increased by 1 there. And then if the count is greater than the initial 0, that'll become, the best word will equal that count. And then the best shift is going to be that word here that was found. And so it'll return the best shift and the real word here. And so we'll kind of take a look and see what that runs here. And so you can see like the plain text message, it's calling that function for a plain text here, to encrypt that hello. We want it to shift twice. And so we're expecting, HIJ would be 2, so on and so forth. And so expected and actual, and then we're loading those words again, and then 24 and hello here. So, because again, yeah, shift amount and then the actual word here. And so, yeah, that is problem three, and then we'll go into problem four here shortly. Thank you.